So I will be reporting about the introduction to collagen. So the introduction to collagen is divided into what is collagen, the structure of collagen, the different types of collagen, the applications of collagen, and lastly the diseases that is linked to collagen. So on the first is what is collagen? So a collagen is a member of family of natural occurring proteins. It is one of the most plentiful proteins present in mammals, and it is responsible for performing a variety of important biological functions. One of the examples of collagen is gelatin, which is used in food and industry. It is a collagen that been irreversibly hydrolyzed. Collagen has many medical uses in treating complications of the bones and skin. So it is most well known for the structural role it plays in the body. It is present in large quantities in connective tissue and provides tendons and ligaments with tensile strength and skin with elasticity. It is often works in conjunction with other important proteins such as keratin and elastin. So next is what is the structure of collagen? So the shape and structural properties of collagen molecule is mainly by its triple helical alpha domain. In classical collagen molecules, a single triple helical domain is observed to compose close to 95% of the molecule. However, there are collagens that exist which has been shown to comprise of multiple triple helical alpha domains, which only account for the fraction of molecular overall mass. So the triple helical domain structure of collagen consists of three distinct alpha chains and earns the name triple-collagen. Each of these chains contains characteristics L-handed amino acid chain sequence of polyproline, often termed as polyproline type 2 helix. So the proper folding of each of these chains requires glycine residue to be present in every third position in the polypeptide chain. For example, each alpha chain is composed of multiple triplet sequence of glycine, YC, Y and C can be any amino acid. Y is commonly found as proline and C is usually present as hydroxyproline. The presence of hydroxyproline in the Y position is also to contribute to the stability of the helical bond. Next is the sources of collagen. Collagen mostly found in the bones, the skin, the ligaments, and fruits and vegetables. So next is what does collagen do? So a collagen is secreted by various cells, but mainly by connective tissue cells. Some collagen act as protective covering for delicate organs in the body such as the kidneys. So it is found in the extracellular nucleus. This is an intricate network of macromolecules that determines the physical property of body tissue. So intermediate or the middle layer of skin, collagen helps forms a fibrous network of cells called fibroblasts, upon which new cells can grow. It also play a role in replacing land or storing dead skin cells. With the age, the body produces large collagen. The structural integrity of the skin declines, wrinkles forms, and joint cartilage weakens. So by the age of 60 years, so a considerable decline in collagen production is normal. So usually women experience a dramatic reduction in collagen synthesis after menopause. Next is what are the types of collagen? So the collagen superfamily of proteins includes more than 25 collagen types, as well as additional proteins that have collagen-like domains. It is divided into fibular and non-fibular. So for fibular, for the type 1, examples are skin, tendons, vascular later organs, bones. For type 2, this is usually cartilages. Type 3, usually reticulate. Type 4 forms basal lamina, the epithelium secreted layers of the basement membrane. Type 5 usually found in cell surface, hair, and placenta. For non-fibular, so facet were called fibular associate collagen with interrupted triple phase. So usually it is known as type 9, 11, 15, 14, and 16. So for short chains, usually a collagen type 8 or 10. So for basement membrane, so it is a collagen type 4. Multiplexing, it is multiple triple helix domains with interruption. So type 15 to type 18. And the massive, so it is a membrane associated collagen with interrupted triple helix. Next is the medical uses of collagen. So what are the applications of collagen? So the uses of collagen forms from the structure of bones, makes makes up cartilage and connective tissue, and prevents blood that is being pumped at high pressure from bursting the walls of arteries. It is the main component of tendons which connect skeletal muscles to bones. So for medical uses, it's usually used for cardiac applications or cardiac surgery, like shown in the figure. And next is the cosmetic surgery, which has a face shown in the figure. And bone grafts, tissue regeneration, and reconstructive surgical uses also have bone care. So lastly, what are the collagen-related disorders? So there are many types of disorder associated with collagen. So these disorders typically occur as a result of improper folding of these molecules and occasionally due to the particular amino acid substitution. So here are some diseases. On the left side, you can see Ehlers-Danlos syndrome, and the bone X-ray shows the Alport syndrome. On the right side, upper right side shows the osteogenesis imperfecta, and the right lower right is the atopic dermatitis.
So, good morning. My name is Richard Manzanares, and I'm here to discuss the recovery of collagen type 1 alpha 1 from a whole corn extract using pepsin digestion and precipitation. So, the reagent grade sodium chloride for the materials, the reagent grades sodium chloride, phosphoric acid, hydrochloric acids with guanine hydrochloride and Thermo-Peace Barfoot's total protein assay were obtained from the Future Scientific whole corn with low expression of the recombinant human type 1 uh, collagen with 2% hydroxyproline content from the 2004 field trial was provided by Prodigy Incorporation as part of the research collaboration with Fibrogen Incorporation. Recombinant human collagen was expressed in uh, Piercia pastoris in a 50-liter fermenter released from the cells by ball milling, and recovered by precipitation after pepsin digestion of the extract of the following procedure in uh, developed in amino acid analysis performed by Fibrogen identified 33% of protein as uh, hydroxylated for a total hydroxylated protein amino acid content of 7.5%. So the pepsin used for extract digestion was recombinant human pepsin stored at negative 20 degrees Celsius provided by Fibrogen. So this is the process flow sheet of the methodology. So first we will talk about the milling and the fatting. Next is the extraction and spiking. Next is pepsin digestion. Then precipitation, total protein microplate assay, and HPLC seg assay collagen content, and then the SDS page. So for the milling and defatting, the whole transgenic corn used containing RCL alpha 1 was cracked and milled using the corrugated mill with slot setting of grit particles less than 0.021 inches. So the grits were ground using the household coffee grinder into a fine powder. So the whole ground corn was defatted in a 20% weight by volume mixture with hexane and mixed in the ice for 1 hour. So the supernatant was separated by centrifugation in a Serval RC6 plus centrifuge, 22 thermal Serval Asheville NC before a second hexane extraction was performed. So the material was allowed to air dry overnight at room temperature and and for prior to storage at negative 20 degrees Celsius. So for the extraction and spiking, for the initial screening for precipitation condition without pepsin treatment, the milled defatted full corn was extracted at 10% weight by volume at pH 2, phosphoric acid with 0.1 1 molar phosphoric acid, 0.15 molar sodium chloride, and 0.5 molar milligrams of RbC1 alpha 1 per ml for 1 hour at 24 degrees Celsius, centrifuge, and decanted. So the pallet was suspended for a second extraction, centrifuge, and uh, centrifuge again, and then the supernatant was decanted. So the combined extracts were filtered and stored at 4 degrees Celsius. So for the additional precipitation experiments, that includes the comparison of pepsin treatment. The same extraction procedure was followed, but the RPCL alpha 1 level was reduced to 0.25 milligram per ml. So, for pepsin digestion is a 20 ml alicate of 0.25 milligram per ml collagen spike extract was digested with 0.20 ml of pepsin enzyme at 40 degrees Celsius, 4 degrees Celsius, giving extra concentration of 195 per ml pepsin of 0.2 and 0.248 milligram per ml collagen. So for the control, 0.20 ml of unspiked extraction buffer replaced the pepsin. Both samples were incubated overnight at 4 degrees Celsius. So for the precipitation, For the in the initial screening of precipitation conditions, three levels of pH and NaCl concentrations were set by the addition of 5 moles of NaOH and sodium chloride. So uh, 2 to 1 ml of extract in 1.7 ml microcentrifuge tubes. So the final collagen levels in a pH 2, 4, and 6 trials following NaCl addition were normally uh, 0.45, zero point 0.4, and 0.35 milligram per ml. So although the mass balance of precipitate and supernatant after pH 6 trials showed uh, losses of 50% of the collagen, the pepsin pretreatment comparison followed the same procedure using the pH 2 and NaCl concentration of 0, 0.25, 0.5, and 1 molar. So the final collagen levels were 0.195, 0.198 milligram per ml for all pepsin treated and control samples respectively. So all tubes were mixed by end-to-end tumbling to uh, on a rotating shaker at 4 degrees Celsius for 1 hour and centrifuge 30 minutes. So the Expendorf model 5424 micro centrifuge. So the supernatant were decanted and the pellets were dissolved into their original volume and spike extraction buffer, and the solution analyzed for content of collagen and total protein. So the all precipitation were replicated 3 times. So for the total protein microprotein assay, so the Bradford Comesi total protein microplate assay from Thermopis was used to determine the total protein concentration relative to the BSA standards. So the HPLC-seq assay for uh, collagen content. So the all samples were prepared by combining 200 microliter of sample with 200 microliter of 4 molar of guan, guanidine uh, hydrochloride hydrochloride analyzed by HPLC, and then the peak areas were integrated using the Agilent's ChemStation software. Then the collagen is now detectable at 220 nanometer, uh, but not at the 280 nanometer absorbance. So the peaks area were integrated using the Agilent's CAMS station software after manual identification of peak boundaries. So the collagen is now detectable at these absorbance, but not in 280 nanometer absorbance. So therefore, the peaks collected at 220 nanometer were identified as the collagen, and peak area was calibrated with injections of the purified RPCl alpha 1. So for the SDS page, is the samples were prepared by 1.2 dilution in preparatory aqueous sample in buffer pH with 8.3 containing 2% SDS, 0.5% bromophenol blue, 10% uh, glycerol and 5% of mercaptanol, and 0.0625 uh, molar Tris HCl in 1.7 ml microcentrifuge tubes. So each sample was vortexed and boiled for 30 seconds prior to loading onto a cast of Tris HCl 7.5% and 4 to 15% gels. So this gel was run at 220 volts using a cold running buffer of a 1.5% risk-based, 7.2% glycine, and 0.5% SDS in the ionized water. So the gels were stayed for 1 hour in 1 gram per liter cu- ano? Cumis blue stain G250 in for 40% volume by volume methanol and 10% volume by volume uh, acetic acid in the ionized water. So the gels were stained in 40% methanol, 10% acetic acid in the ionized water. Molecular weight standards ranging from 10 to 15 kilodaltons uh, were run in the adjacent lane. So for the RIPP scheme of the methodology of the recovery of collagen type 1 alpha 1 from a whole corn extract using pepsin digestion precipitation. So the recombination of human type 1 collagen was expressed in transgenic corn, and then for the recovery and isolation, they do myelin and defatting, extraction and spiking. For purification, is they use the pepsin digestion and precipitation. So for the polishing is a total protein microplate assay, HPLC seg assay for collagen content, and then SDS page. So the product of this procedure is the extract containing RPCL alpha 1 collagen and the corn proteins.
Hello, I'm RJ Tacas and I'm here to report about the bioseparation processes used in the proposal. So for the cell disruption method, ball milling was the chosen method in order to do cell disruption. So this cell disruption method uses glass or ceramic beads and a high level of agitation. This requires a closed container to hold the sample and an electric motor that can provide rigorous agitation. So the factors which are taken into consideration is the efficiency and the cost of the method. Since bead milling can be used in order to process multiple samples and it is also inexpensive. An alternative way for cell disruption is the sonication process. It involves a high frequency to be generated electronically and a mechanical energy that is transmitted to the sample via a metal probe that oscillates with high frequency. Then, like bead milling, it is also a physical method of cell disruption. And the problem with both of the methods is that they have a variability in their yields. So this is the feature for the cell disruption method that's alternative, which is the sonication process. So it requires a container to hold the sample and the ultrasound generator in order to produce the high frequency waves. Centrifugation was used in the experiment in order to get the collagen spike extract after the process of defatting the sample. Centrifugation is a technique where a device is used in order to separate particles from suspension or macromolecules from solutions. So the basis for using centrifugation process are size, shape, and density. The limitations of centrifugation is that it can only be used when the dispersed material is denser than the medium in which they are dispersed. So an alternative for centrifugation is what we call sedimentation. It is also a particle liquid separation process like centrifugation, and the principle behind the two process, the sedimentation and centrifugation, are the same, which is achieved through gravitational field. So The requirement is that the material should be denser than the medium for the sediments to settle in the bottom of the container. The basis of operation of sedimentation process are the density and shape of the molecules. Next is the precipitation. To purify the obtained extracts, precipitation was performed with toxin pretreatment. Precipitation is a known method for purifying proteins and nucleic acids. The basis of separation via precipitation is solubility. Factors that can be used in order to precipitate biological macromolecules are cooling, pH adjustments, addition of solvents, and addition of chaotropic salts and anti-chaotropic salts. So size exclusion chromatography was conducted in order to elute the collagen from the host cell proteins. So the principle of size exclusion chromatography is based on the use of inert porous particles as stationary phase, and this separates solutes purely on the basis of size. Size exclusion chromatography was used because the collagen have significantly larger molecular weight than the host cell proteins. Um, Size exclusion chromatography was also a simple, rapid, and reliable tool for antigen particles assembly analysis. So lastly, they use SDS stage. Uh, it is a type of gel electrophoresis. Electrophoresis refers to separation of charged solutes based on their electrophoretic mobility. The basis of operation for electrophoresis is the electrostatic charge. However, the molecular weight of a substance also influences other properties of the material, such as sedimentation, diffusivity, mobility in an electric field, and hence can be an indirect basis for separation in electrophoresis.